In this problem, we're once again going to graph a trigonometric function using the 5 key point methods, but in addition we have a vertical shift component. We want to graph y equals -6 sine pi over 3x plus 4. This plus 4 means that the graph is going to have to shift up 4 units. We're going to start by noticing that the value of a is -6, which means that the amplitude of the function is the absolute value of -6, or 6. So the graph initially, without the vertical shift, is going to oscillate between -6 and 6. Next, we notice that the value of omega is pi over 3, and so the period is 2 pi over 3, or 6. That means that it will take 6 radians to draw one complete cycle of the graph. So initially we're going to start the graph at x equals 0 and end the graph at x equals 6. We divide that interval into 4 subintervals, so 6 divided by 4 is 3/2, and that tells us that the intervals we're going to be looking at are going to go from 0 to 3/2 for my first subinterval, 3/2 to 3 for my second subinterval, 3 to 9/2 for my next subinterval, and 9/2 to 6 for my last subinterval. Remember, the endpoints of these subintervals give rise to the key points on the graph. The graph starts at x equals 0. Because this is the sine function, my initial key point is going to be 0, 0. My next key point is going to be 3/2 comma -6 because a is -6. My next key point is 3 comma 0. Then 9/2 comma 6. And finally 6 comma 0. What I'm going to do is plot these key points and then draw in the graph of the sine function without the vertical shift component. Then we'll shift the graph up 4 units. So we start by drawing a Cartesian plane. And what I'm going to do is have the y-axis go between -6 and 6. And let's make this 3/2, 3, 9/2, 6, then -3/2, -3, etc. Now what I do is I plot my key points. 0, 0, 3/2, -6, 3, 0, 9/2, +6, 6, 0, and so on. And then I can continue in the negative direction as well. So I trace in my curve, the sine curve, and I obtain this graph. So this is the graph of y equals -6 sine pi over 3x. Now, because I want to graph -6 sine of pi over 3x plus 4, I'm going to add 4 to the y coordinates on this graph. So I draw a second Cartesian plane. And this time my max y coordinate is going to be 10, and my min y coordinate is going to be -2 because I'm shifting the graph up 4 units. Then I scale my horizontal axis. 3/2, 3, 9/2, 6, etc. -3/2, -3, -9/2, -6. So let me label those scales. And so now, like I said, we're going to add 4 to each y coordinate. So instead of 0, 0 being on the graph, it's going to be 0, 4. Instead of 3/2, -6, it's going to be -3/2, -2. Instead of 3, 0, we're going to have 3, 4. Instead of 9/2, 6, we're going to have 9/2, 10. A little squished there. Instead of 6, 0, 6, 4, and instead of 15 halves negative 6, it's going to be 15 halves negative 2. And we could do that in the negative direction as well. Negative 3 halves 10 will be on the graph, negative 3, 4, etc. And now I just trace in the sine curve, and I have a complete graph of y equals negative 6 sine pi over 3x plus 4.